Welcome, everyone. Good morning and good evening. My name is Arjun. Uh, I help build VMware's SaaS commerce platform, which is a foundation for most of VMware's newer breed of SaaS products. I am keen about enterprise agility and how we can move businesses forward, as well as improving my personal agility in my 10K plus races. Over to you, Balaji.
Thanks, Arjun. Hi, I'm Balaji Parthasarathy. I take care of enterprise architecture for VMware, supporting all VMware business applications. I'm very passionate about DevOps as a culture. I'm probably leading that through the domain-driven design constructs to make it real. So that's a quick introduction about me. Arjun, I think we can go to the next slide. Okay. So before we get deep into what we are going to talk about today, probably it is already a year from now. That is basically a year ago when the pandemic started surfacing, right? The difficult time started. But at that point of time, probably there was a brighter side as well. That's what I thought. And why not invest? Because probably I thought there is going to be some decent time, travel time is cut down. So is there something that I can invest on something? And I wanted to invest in my hobby. So what I wanted to do is probably learn a couple of musical instruments, probably to start with is one musical instrument. And then what typically anybody does with respect to hobby is start searching web, browsing it, what does it suit, and then start buying the musical instrument, right? So if I reflect back a year from then, right now, probably I would have bought 2 to 4 musical instruments. But have I gained the expertise on that? Have I learned it? Have I practiced it? Probably no to that extent, right? So it's basically a reflection of what we typically end up in terms of when we try to solve a problem. When we try to solve a problem, we try to go identify the tools, the new toys in the industry or system, start trying it. But the question is this the right tools that to be used and how to use it? So today's session, instead of talking purely in terms of how, we are going to touch upon two fundamental aspects: why we do what we do, and what we really need to be doing before we embark on how journey. That's basically the three constructs that we'll be touching upon. So starting with in terms of what are the barriers to monolith architecture, why it is a barrier, what we need to be doing to solve this problem, and how we will be solving this problem using domain-driven design constructs, and then a practical guide to transitioning from monolith to modern applications where microservices is a subcomponent of it. That's what would be the agenda for today. So fundamentally, to start with, right, we are going to talk about the why component of it. So what is a DevOps culture, right? Basically, everyone is talking about DevOps culture, but are we leading it with a proper DevOps culture? Before we break DevOps and culture, let me talk about what is culture, right? I heard this couple of days before. A culture is something we do when no one is telling us what we should be doing, right? So in that sense, it is well institutionalized within the organization in terms of what we should be following. So if you go back to the wiki definition of what DevOps is, this is a wiki definition of DevOps is, there are three components which is standing out. One is it's a practice or a culture aimed at shortening the life cycle of the software development. It is a continuous delivery, and the objective is to deliver a high quality software, right? So these are the three three components or key definitions of a DevOps culture. And to make it DevOps culture real, what's happening is that the very classical question that is asked is, if I check in a blank line of code, how long it takes to get to production, right? Production is when it sees the market, when the code is treated as a value, right? So in this context, when the code is checked in, it is not the logic of the code, but how the code is going to be tested, integrated, released and deployed into the production, which is what we call the last mile, is always taking longer time. The objective of DevOps is basically bring the ops equal into the DevOps culture or dev culture, start treating everything as a code, including configuration as a code. So that the objective is to eliminate the last mile, or reduce the last mile, right? So that's what we are aiming at from a DevOps culture. That's why we are doing certain things, because it is basically aiming at faster time to market. Arjun, and the next slide. Arjun, in this context, right, we have been talking about DevOps as a
Mhm.
culture and what we should be doing. The question is, how is industry measuring these in a very crisp way? How industry is measuring these the progress in DevOps, and where do VMware IT stand today?
Sure, Balaji. Uh, Culture is great as a concept, right? But engineers want hard numbers that they can go back to. And there are a couple of metrics that are now industry standard to measure the maturity of any DevOps organization. Okay, one of the primary ones of that is how frequently do you deploy code into production using automation, using CI/CD pipelines, or whatever mechanisms where you've removed the last mile barriers so that code from commit into production environments can flow seamlessly. And what we have observed over the few years that we've adopted DevOps practices at VMware IT, as code deployments have increased by 250 times. Okay, that's a phenomenal number, but that's brought about by a combination of practices, automation, and the DevOps principles. Now, uh, it's one part is how frequently we deploy, right? The other part is the entirety of the last mile that Balaji referred to earlier, right? From code commit to availability on production. How is that time shortening as organizations go through their maturity cycle of DevOps? And what we have seen specifically at VMware IT, as our DevOps culture and practices and the automation around it have matured, the commit to deploy timelines have become over 200 times faster. That means quicker time to market, easier availability to features, and obviously business operating at the speed as is required in a post-pandemic world. Now, speed is great, but just speed is not enough. We need to ensure that businesses in their focus on speed do not impact the experiences of customers. So another important metric of that DevOps measures is the change failure rate. How many times have changes failed or caused issues when you deploy? And and this is expected to go down over time as organization DevOps cultures mature and the practices mature. At VMware IT, when we looked at the last couple of years worth of data, change failure rates have gone down to nearly negligible rates. Okay, which means that there is a repeatable process that can be deployed across multiple tech stacks and environment to ensure that code does not break once it reaches the production environment. Now, what are the objectives? Balaji, in your mind, when we look at the ever shortening time to market that businesses are not demanding, as well as the obsession with customer experience, what are the primary goals for
Yeah, yes,
organizations that are
Arjun.
going through this journey?
Yeah, exactly. It's a journey. At the end of the day, the maturity that we have achieved, basically, we are measuring with these three metrics, right? The maturity that we have achieved starts with something, and that something is basically in terms of how we architect things to be much better, because it's something like it's not only the end of the tunnel need to be faster, right? You need to start from the beginning, and to make it keeping our anchors on two fundamental goals that we want is basically faster to production and high code quality. To make it happen, there are two fundamental things that we embarked upon, basically in terms of architecting things, but also a contained code base as well as a contained team having a control on that code base. So what it means is basically, if it is going to be a big ball of mud, what we call monolith, there are multiple teams going to work on the code base, and probably there is not going to be any probably a full control in terms of what is going to happen when one touches the code, what is an impact on that, right? The objective is to make that code base very contained as well as it's a very contained team having a very focused code base. This is what we have been starting with. And to make it happen, we need to build probably a purpose-built architecture. And this purpose-built architecture obviously leads to the microservice constructs from a monolith to a microservices construct. Arjun, in this context, being part of this journey, right? What are the key barriers of a monolith? What is why monolith seems to be a challenging affair today?
Sure. Well, one is obviously what we spoke about, right? Changing the culture and making sure that everybody across the organization is invested into the DevOps mindset. But the primary barriers that we see are the technical debts that have been accumulated over a period of time. All the code, all the infrastructure that has gone in, our code that we accumulate as tech debt, and we end up paying the interest. And the barriers over there are, agility, the speed, the time to market, and the confidence that we are able to change these ballooning monoliths and be able to move forward. Okay.
Yeah, I would
Uh,
like to add one more
yeah,
point,
sure.
Arjun, right? In this context, as you said, the culture need to typically change to start treating every code as a technical debt, because what is valid today, the organization would move ahead, technology would move ahead. So which means start treating everything as a technical debt, and how we manage those technical debt in a very contained way to keep the interest under control would be a success. Probably that's what I would call a success.
Absolutely. Okay. Let's talk a little bit more about monolith biology. Okay. And what are some of these debts?
Yeah.
Okay. Now, some things that really hold organizations back from being able to scale or move forward with agility are things that you see over here. Tight coupling of components, okay, where applications which start off as really small ones for a particular business need, then grow and expand over time so that it becomes very hard for them to be separated out. Uh, Complex code bases. And Balaji, we move forward, right? I mean, if we have some of these monolithic applications where components are really tightly tied together and grown and expanded into complex code bases, in your experience, what has that led to?
So when it comes, see, the problem is the confidence level, as we talked about, right? The confidence level of the team to understand impact on the code or impact on any changes that is being made. Is it contained and what need to be done? And that's where it always lead to a last mile to be longer than what, if you take 2 days to check in the code or write a code, it would be 5 days to do get to the last mile, right? So that the complexity of the code brings in the low confidence level, which the team need to address. And obviously, the solution to these two fundamental problems is a loosely coupled architecture, um, and also simplifying the code base in terms of very contained code bases that we call microservices. These are the two foundational solutions that we embarked on when we started architecting it, right?
Okay. And I mean, see, organizations that are still going through this journey, the other things that they may notice, right, is it takes really long time to go to market with any features. The applications by themselves become less scalable. And the net effect of these complex code bases and the tight coupling is the availability of the application does not really scale up to what is required in a modern context. Okay. Now,
Arjun,
before we,
if I can,
yeah, yeah,
if I
sure.
can stop you in this, right? It's a good conversation, but the thing is it practical to start breaking the whole ball of mud or monolith into this and achieve these goals, or how do you think we should be solving this problem? I know you're covering it in a couple of slides from now, but if you can give us a flavor of what we are trying to solve and how we are trying to solve.
Okay, sure. I mean, see, there is no magic bullet, right? You can't just decide one day that, hey, guess what? We're going to just make our monolithic applications dance and spin up a few microservices and we are done. It really doesn't work that way. It takes time. It takes a very structured approach in how we define the domains and the architectures, and gradually uh, start breaking apart the monolith. We're going to talk about it in a little more detail further on in the presentation. But probably what I'm going to start with is, you know, a little bit more about this magic bullets that are, I mean, always said, hey, uh, make your applications on public cloud, and magically everything is going to get modernized, or adopt a particular tech stack or a platform, and things are going to, become so much better and scalable. We'll start this off, Balaji, maybe with some analogies. Okay, on
Sure.
what are these approaches to platforms and breaking apart monoliths? So we've heard these acronyms more frequently now post-pandemic than otherwise, right? About infrastructure as a service, platform as a service, and SaaS, right? So what's the best way to, spin up an analogy to explain this? Okay. So the traditional on-premise applications, and let's take the example, let's say of a cell phone car, right? Where uh, the customer is responsible for the vehicle itself, the maintenance, the insurance, the driving, navigation, registration, everything, right? Everything from soup to nuts, completely owned by the customer. Now, let's look at some of the advantages that we get when we get into a rental car. Okay. Yes, the customer is still responsible for paying for it, the driving it, and parts of the registration and insurance. But the actual maintenance and upgrades is taken up by the rental car agency. Okay. Uh, and if you move forward, if you get to ride sharing applications, the only thing that the customer is responsible for is the navigation and the payment part of it, right? Everything else from the vehicle, the drivers, the insurance maintenance, completely taken care of by the organization which is providing this. And we can equate this as your uh, everything cell phone car is equivalent to a legacy application where maintenance upgrades are taken care of by a provider or a service provider that's closer to the IaaS or infrastructure as a service organizations. And when pretty much everything in terms of how you drive the car and the insurance is taken care of by a service provider, that's more platform as a service. And the closest analogy to a SaaS software is public transport, where everything from the route, the capacity, where it goes, the driving, and the vehicle is taken care of by a service provider. And we can equate some of these over to the different stacks that we have in traditional applications. If you move forward and look at it from an application or a platform mindset, these are the different components that make up any enterprise application stack: the compute, storage, networking, the hypervisor, assuming everybody is virtualized right now, the containers, the applications, and the functions and the data. As applications and enterprises mature in their modern apps journey, more and more they can make the choices. It is not a recommendation that one is better than the other. It is the measured approach in what works and what is most efficient and derives the most value that we are able to make the choices. Okay, so Balaji, I mean, let's have you us walk through on a structured approach to how we can actually embark on this journey with an architecture first mindset.
Sure. Thanks, Arjun. So typically, as a monolith that we have been introduced to, how we have been used to, right? It's always based on layered architecture. The objective of the layered architecture is it's a well-defined technology stacks that we will be using, but at the same time, it's very structured in terms of how the one component of the architecture interacts with the other component of the architecture, right? Now, typically what happens is when you have such an architecture, uh, you need, when you start building or delivering a project, you need to have multiple teams come together to solve this problem. And obviously, there is a lot of handshakes, and then there is potentially there's a gap in terms of how these interactions would happen and lead to the complexity of the code base as well. Um, so, so the way that we are looking at from a microservices construct is, can we solve the technology problem first, right? And to solve this technology problem, is one stack of technology can solve all layers, and that's what we call in terms of the microservices architecture. Arjun, you want to? Yeah. So to get there, fundamentally, what we need to start looking at is start driving the organization towards domain-driven design constructs. To make it happen, start building domains within the organizations. The domains are called the problem space, and the business domains is something like a marketing domain, finance domain, and so on. That's basically you start with segregating the business functions and the applications into these domains, and then obviously we inherit the monolith. So what means we inherit the layered architecture as it is. And based on Mervyn Conway's law, what he found is basically in 1968, I believe so, when he tried to create a compiler for COBOL, he tried to create two teams and another three teams, right? So basically two set of pilot teams with two sub teams and three sub teams. And then he asked them to create a compiler. What he ended up is primarily two-layered, two-stage compiler and a three-stage compiler. So what it means basically is conclusion or hypothesis is organizations do design systems, but it's always constrained by the communication patterns within that organization. So that drives the architecture. So in this layered architecture, to solve the problem, all these tech stacks need to come together to solve the problem. Now, once we started defining the domains and then segregating, the team found a solution to this. Is basically, do I need all these tech stacks to solve this problem? Can I deal it with the one tech stacks, and then that tech stack will solve all layers of the problems and the interactions becomes easy. The middleware layer will slowly start disappearing in these architectures and so on. And it starts evolving into microservices and a very contained code base, a purpose-built code base that solves the problem. That's in what we call applications of microservices here. And then the objective of it is make it faster, containerized to take it to the next ecosystem, primarily from dev test to production and so on. It makes it very easy, right? So that's evolving. And then over a period of time, it should also be solving the problem of transitioning across multi-cloud constructs, starting from a private cloud to hybrid cloud to public cloud. It has to be as seamless as anything else. That's basically the whole solution evolved with respect to transitioning to a microservices architecture. Arjun, you want to? Yeah. So I want to talk about, Arjun, what did we really achieve out of this modern application architecture? What were the benefits that we achieved? And how do you see it in the maturity level in VMware IT today when we compare it to these benefits?
Okay, sure. So, adopting a very measured domain-driven approach to breaking apart the monolithic applications that we had made sure that we have services that are purpose-built and they serve only one purpose, right? And what it also means is the removal of the tight coupling and the complexities that that applications exhibit because of that made the entire ecosystem a lot more resilient. Resilient not in terms of outages that could happen, but also resilient to changes. The applications were much more better suited to be modified and morphed and enhanced for a particular purpose-built service rather than having to change the entire monolith. What this also helped us is move it forward into our multi-cloud journey. Enterprise applications traditionally have been on-prem based and limited to some of the legacy tech stacks, but now because applications were decomposed into services that would scale independently, it became a lot easier to move to multi-cloud. In fact, the main benefit that businesses saw was orchestrated releases for a particular feature or a particular subservice instead of having large quarterly windows of releases. which made isolation easier, scalability easier, and applications were immutable to changes that may happen in other parts of the ecosystem.
Arjun, quick question, right? In this context, there is a myth that I need to go into a microservices of architecture to containerize or make it faster. Do you want to talk about it?
Sure. I mean, microservices is one approach. Okay. So probably what I'll do is take us through an example uh, of how we can go about it. But where I would start off is that microservices in themselves will not solve it unless we start with a domain-driven design. Okay, and that's what we've learned the hard way. Even though microservices is the current industry buzzword, unless we take a measured approach from an architectural standpoint, uh, just writing microservices doesn't solve the problem. Okay, maybe you want to take us through a little bit more, Balaji, in what it really means to do domain-driven design from real-world examples.
Sure, Arjun. Uh, so let me introduce the concept of a domain-driven design. Okay, what do we mean by it? Let's look at domain as a problem space. That's where we say these are your functional domains: marketing domain, finance domain, payment as a domain, and so on, right? And what are we trying to solve here? Basically, what we are trying to solve is how do we evolve a contract-based interactions between these domains, and whether these domains are the right domains per se, right? In a very consistent way. To start it, we need to start with something called ubiquitous language. Ubiquitous language is nothing but a business language that is consistently understood in the same way within the domain by the business teams, the developer, the architecture teams, and all stakeholders, right? A simple example is when it comes to a billing domain, okay, the computed billing build value is called a billing document. But when that transitions from a billing domain to an invoicing domain, it's called an invoice because it's what is sent to the customer. The content can be the same, but the way that it is understood in the billing domain is different from how it is understood in the invoicing domain. So the ubiquitous definition of those terminologies will change from domain to domain. And that's where you start the foundation on it, right? So you start defining those domains based on ubiquitous language, and what it will evolve into is what we call bounded context. Basically, there's a context of a business terminology which is well bounded, and that's where it gets started, all right? So which means there are opportunities or situations where one subdomain can evolve into multiple bounded contexts, because we even within a subdomain, the interpretation of this business language could be different from one bounded context to another bounded context. Now, once I solve this bounded context and evolve a bounded context, now we should be very clear that interactions across the bounded context, what we call the bounded context is surrounded by an anti-corruption layer. And the interactions across the anti-corruption layer happens in a very structured contract-based models, what we call services. The handoffs are very contract-based, and these services is, is owned within the bounded context. So which means, say, for example, if I want a customer information, it is in the bounded context of a customer, and the customer bounded context owns these services, and these are the service owners of those, right? So then over a period of time, you will evolve core domains, which is basically a domain which is responsible for generation of revenue or cost saving or whatever may be, but it is the core of that whole context. And then there is going to be supporting domains that is going to evolve over a period of time, right? And that whole model of architecting is called the domain-driven design constructs. And then based on it, you will start evolving models. And then each of these models can be carved out from the monolith and become an independent entity by themselves, which can evolve into those microservices constructs, or it can be purely containerized without necessary to go into the microservices. That's the way that we evolve domain-driven design constructs.
Okay, Balaji, could you help explain it to the team using an actual example?
Yeah. So this is an example that we have at this point of time. Most of our customer interact through what we call My VMware. My VMware is a portal where the customer looks or reviews their entitlement, operates on their entitlement, do the license management on their entitlements on these My VMware pages and so on. The underlying this My VMware is the entitlement management system, which was a monolith when we designed it. And then what we did is, over a period of time, we started carving out the monolith into, or rather chipping the monolith into a set of models and domains that you see here. Basically, starting with an entitlement subdomains, support subdomain. Support is basically where I file my SRs, get my support, and so on. Licensing subdomain, and so on. So basically, you start carving those subdomains. Those subdomains evolve into the bounded context. As I said, it could be a situation where it is one-to-many situation, where one subdomain can have multiple bounded contexts. But in this case, we ended up one-to-one. License subdomain evolved into a license entitlement context, and support entitlement context for support subdomain. And they interact through the anti-corruption layer that you're seeing on the border through well-defined contracts. So which means the service ownership of licenses within this license subdomain and context, bounded context, and support services could be multiple support services within the context of support entitlement evolved. So what happens is, over a period of time, it is not only supporting the My VMware portal, but these are the services that is exposed to multiple other consumers, including partners and other ecosystems as well.
Sure. So what should be the approaches that teams take to chip away at the monolith?
So, as you called out, Arjun, very clearly in the beginning, right? It's not you wake up one fine morning and say, I will break this monolith, convert into microservices, and move on, right? That's not going to happen. So, the way that you start working is start chipping up. What it means is basically start putting in your paper what these domains and subdomains look like, what these bounded context architecture would evolve into, which would scale and stand up over a period of time, and then carve out those models. The model within that model is a domain-driven design, which has both the subdomains and well-defined bounded contexts and interactions across these bounded contexts and service ownership. And then you carve out that model, and over a period of time, start converting these models into modern applications. The modern applications again falls into two buckets. One is, if there's a need, you can still go through microservices constructs, or you can still containerize that whole model and start evolving and moving into cloud, right? So you can decide based on the return on investment and how we want to spend. For example, one of the model is going to be an end of support, right? It doesn't have a future. So do I need to spend energy, time, and effort in converting into modern applications, or it's better to keep the model as it is, but as long as it can be containerized and move into it, because it doesn't have a life of its own after a couple of years, but the model one has a life and I would like to modernize, right? So you need to make judgments on your investment and evolve accordingly. So that's how I see it evolve. It's not one fine day you say I will break the monolith and start breaking the monolith.
Okay, sure. Let's take the team through an actual structured application coding an example. Okay, let's start with a monolithic application that began its life a few years ago when a company, let's say, just decided to go the e-commerce route. And we used layered design for UI, application logic, data access, and a database. Multi-layered features started getting added up. And it became, over a period of years, very complex. And complexity has challenges. Uh, Challenges in terms of individual components cannot be scaled. Challenges in terms of it becoming very complicated to maintain, provide the scalability that it needs, and even being able to, difficulties for newer engineers to come in and even have problems or challenges in understanding the code and the complexity behind it. Now, as we said earlier, right, the starting point to breaking apart the monolith is by defining what are those bounded contexts. And let's start with the logical bounded contexts that are going to exist for any e-commerce applications, like the products, the ordering systems, the users or the customers, and the payments part. Now, once we have defined these bounded contexts, then the approach that we take is a newer capability that is built is no longer built as part of the existing monolith, but it is created as a brand new service, which can be independently deployed. But of course, due to the interactions that are still required with the monolithic applications, we use glue code or what is called the adapter pattern, right? So that any interactions that are required with the monolith can still continue, even though the new service is not constrained to the same challenges as the original monolithic applications. Okay, and in this manner, we slowly start to build out new capabilities as new services, which could be independently deployable using a glue code or the anti-corruption layer to help make sure that all the transactions or interactions still continue to happen so that existing feature sets are not broken apart. The next logical place is really separating out the experience layer or the UI layer as completely different from the overall monolithic applications. And we introduce something new, a facade layer or an API gateway through which all interactions will continue to happen with the application. Now, what this does is gives us an opportunity to have a standard way in which the experience layer can interact with the underlying application without being aware of whether that application is monolithic as or it has slowly transitioned into a modern app. Okay. And what this allows us to do, if you go forward, is start expanding on the services that we gradually start to decouple away from the monolith and make it available for the experience layers through the API gateway. Increasingly, these are direct interactions between the API gateway and the modern application or the modern services, right? There are still some interactions happening with the monolithic code base as we start chipping away at it. This particular model is called the strangler model. So what you're essentially doing is strangling the monolith, making sure that new capabilities are no longer built on the traditional applications, but are start increasingly getting separated out. And you're able to get to a point eventually where all these services are split out by the bounded context that we had defined. And in fact, at its final end state, even the data models can be segregated out based on the bounded context that we've defined. And this is the full decomposition of the original application, which has a highly flexible presentation layer. You have services based on the bounded context that we've defined and data models. All of these are now independently deployable, independently scalable, and we can roll out features for each of them without impacting the entire application.
Arjun, one question, right? How practical it is when it comes to the orders, payments, and other things where it is very tightly coupled with an ERP, which is a
Mhm.
monolith in one sense. How do you solve this problem? How practical it is, and how we have addressed this?
Sure. See, ERPs are not going to go away. For any large enterprises, there is always going to be core business functionality that stays with the ERPs. What we've done is make sure that none of the experience layers are directly coupled with the ERP systems. We've abstracted out core features that are required for experiences to happen into a set of services that are decoupled, into a set of data models that are decoupled, and then we use eventual consistency to make sure that business transactions can proceed in the actual ERP systems. It's a combination of understanding these subdomains and the bounded context, being able to completely decouple the experience or the user experience from the monolithic applications and then deploy it to scale.
Thanks, Arjun. I would like to add that, right, as you introduce the concept of eventual consistency, it's a cultural change for the organization as well, where the expectation is real time, but all when the transaction is happening, but also in an eventual consistency model, probably there is going to be delays with microseconds, or it could be lesser than that, but or it could be little when it's a certain failure happens, it could be broader than those SLAs as well. So how do I continue my business in these eventual consistencies requires a broader conversations, agreement across the business stakeholders, not restricted. It's an IT decision. It's not only purely an IT decision.
Sure. So Balaji, would you want to go ahead and talk about VMware IT's transformation to modern applications, starting with the scale at which VMware IT operates and where we are in the journey?
Sure, Arjun. So as we talked about in this journey, we have been very conscious in terms of what are those moments that requires microservices constructs. What are those moments requires app modernization, need not be microservices, but it could be containerizations and so on, right? But the objective all be remaining the same in terms of ability to move fast with respect to deployment, value to market, right? So what we did not fall into the bimodal IT trap that Gartner was talking about, that one component can be faster, but it is okay for some other components to be going slower than what it is required. We wanted every application, be it in terms of customer facing applications or business supporting applications, were measured in the same uh, speed, right? Or same set of metrics in terms of how fast you can deploy, and then what is the feature velocity that it means. So this has led to a situation where obviously the maturity levels for multiple systems could be different, but everyone is measured on the same scale and moving towards at the same speed. So which means we are talking about a 400 plus on-prem applications on as well as 100 plus SaaS applications being measured on the same way in terms of feature velocity and in terms of DevOps metrics, the DevOps maturity, as well as the time to market, so on, right? We are talking about at any point of time 50 to 60 big projects being executed at a point of time. Obviously, lines of code is no more a valid metrics at this point of time, but this is an indication of the effort involved and how we orchestrate all these efforts together to achieve the same goal. Talking about 1,000 plus active user stories being executed, so which means in a distributed environment and the cross-functional features would touch upon multiple systems and how these orchestrations happens in a way effectively without creating a problem, right? That's going back to the fundamental philosophy of loosely coupled architecture that we are talking about. And we are talking about here again a 60 plus technology stacks working
Sure.
together.
So have we reached the ultimate nirvana state of maturity to modern apps? Uh, where are we really in the journey?
So it's always aspirational, Arjun, in terms of where we want to go, but we are probably in the middle way in terms of coarsely grained services rather than a finely grained microservices constructs. And is it a question is, do I need to get there or this is the right place to be? That's what is going to is being determined. As I said, it doesn't make any sense to automate or completely change when that doesn't make any sense, right? Or when
Mhm.
there is no return on investment or it's over engineering, right? That I would call it. So probably the right phase is in between the course train and microservices, probably a few steps from where we are today. This is also considering the constraints we will be operating with respect to the packaged applications like ERPs or even SaaS applications like SFTC, where we are trying to abstract out the interactions with the user experience layer through microservices constructs, but we may still deal with the applications or monoliths, which is going to be the reality that we are going to deal with. But one thing fundamentally that has changed for us is in a traditional way, the availability of the system was a responsibility of infrastructure. But as we say today in a cloud native world or a microservices world or in terms of a modern application world at a broader sense, we are talking about infrastructure can make sure application availability, but applications should start dealing with infrastructure non-availability. So that's a big cultural shift in terms of what we need to be doing at an application layer to continue the business continuity and experience of the partners and customers are intact, and how these availabilities are brought in place using various solutions and patterns. But this is making sure there's a drastic change or dramatic change in the way that we start architecting solutions from an application standpoint.
Sure. I mean, that's a mindset change as well for engineering teams,
Yeah,
right?
correct.
Traditionally, application engineering teams have left it to infrastructure to take care of most of their needs in terms of capacity and availability. But right now, we have to change the way that we even design and build these applications that are able to survive and automatically resurrect themselves in case of infra availabilities, unavailabilities. Okay. Okay. So,
So
what are the key things for the transformation, Balaji?
okay, Arjun, as we talked about, right, it's a quick summary of what is important. The infrastructure provisioning and way that we did yesterday doesn't hold good in a cloud native world or a modern application world where the developer needs a full control on infrastructure. So which means starting from provisioning, which is basically the initial wait time is completely reduced. As we talked about the last mile problem, this is the first mile problem where setting up an infrastructure, ready to use infrastructure in the hands of the developer becomes very important. Then architecting for a cloud native construct, starting with your foundational aspects of start defining the domains very clearly, start breaking those domains, evolving models to start interacting in services based constructs, and then decide whether you want to go microservices route or containerization without microservices or so on, right? So that's basically a step towards becoming a cloud native, basically starting with cloud ready to cloud native, I would say, right? That's an evolution that you would have to do. And fundamentally starting with the culture of DevOps, where everything is treated as a code and primarily looking at everything as a technology debt and that we need to be evolving, right? The automation it's completely utilizing the value of automation to a greater extent. So these are three fundamental pillars of transformation that
Sure.
we are talking about.
Okay. And for teams to take away, right, that are either embarking on or midway through their journey to modern applications, uh, think about experiences first, right? It is not always public cloud that is going to give you the experiences that you need or the availabilities that you need. Things can be architected on private cloud too. To as long as you follow the architectural constructs as we spoke about and a measured approach to know what is worth decomposing, you can still achieve what you need. Re-architect applications again based on ROI. Sometimes rehosting may be good enough. Sometimes just containerizing may be good enough, right? Uh, Security becomes a key as you start decomposing into hundreds of services from a tightly coupled application. Uh, so you have to build this as part of the SDLC cycle itself in all aspects of it, all the way from architecture, all the way through testing and production tests. Uh, Measure what is going to be in success for you. We talked about the three main measurements for DevOps. That's the only way that organizations can gauge how successful they are in that journey. Uh, the last mile, breaking that, we spoke about it at the beginning. The only way you can shorten those time to market windows is via automation and tool chains. That is pervasive. That may be different sets of tool chains depending on business environments or domains or technology stacks. Uh, but this has to be something that is fully automated and increasingly automated, infrastructure as a code and everything as a code to be really able to achieve the values that we need. Anything else that you want to add, Balaji?
No, I think that's a good summary, Arjun.
Okay. Okay. So for everyone on this call, if you want to hear more about the VMware on VMware programs, here are a few ways that you can go about. We definitely have an email address that you can reach out to. There are the VOV blogs, as well as our Twitter handle that you can go and read more about the work that VMware IT is doing, delivering the next set of modern applications using VMware SDDC stack. So we do have a few more webinars planned over the next couple of months. There's more on modern applications and containerization, running large ERPs on vSphere, disaster recovery as a service, and application load balancers. So watch out for these to learn more about how large enterprises are transforming themselves digitally in a post-pandemic world. And hopefully you can use some of this knowledge in your own organizations. Okay. We will pause here for